You can also use trigonometric ratios to find angle measures. So just remember, sine compares the opposite side to the hypotenuse, cosine compares the adjacent to the hypotenuse, and tangent compares the opposite to the adjacent. So up here on our first example, we are looking for angle R, and we know both the opposite side and the hypotenuse. So which ratio compares the opposite and the hypotenuse? That would be sine. So we could write that the sine of R is equal to the opposite over the hypotenuse, or 7 over 13. So in your calculator, then, you want to use your inverse sine function of 7 over 13, and that will give you the measure of angle R. And my calculator tells me that that is 32.6 degrees. Now let's talk about angle P. So I'm going to get rid of my old labels of opposite and hypotenuse because they won't hold true for angle P. Actually, the hypotenuse will. This is still the hypotenuse of my triangle. That's still true. But the side that's 7 in length, QP, that's not my opposite anymore. Now it's my adjacent. That's adjacent to angle P. So I need to think about which ratio compares my adjacent to my hypotenuse, and that would be cosine. So I can write that the cosine of P is equal to the adjacent, which is 7, over the hypotenuse, which is 13. Then if I find my inverse cosine of 7 over 13, that will tell me the measure of angle P. And my calculator tells me that that's 57.4 degrees. Now, if I've done everything right, these two should add up to 90, which they do. That means that angle R, which is 32.6, plus angle P, which is 57.4, plus angle Q, which is 90, add up to 180 degrees. That's just a way to check your work and be sure that you got it right. So now pause the video and take a moment to figure out the measure of angle Z and the measure of angle Y using trig ratios. So I wrote that the sine of Z is equal to the opposite over the hypotenuse, and then I found the inverse sine of 14 over 23. That gave me 37.5 degrees for angle Z. XY is adjacent to angle Y, so I found the inverse cosine of 14 over 23, and that also gave me 52.5 degrees. So let's see if it all adds up. 37.5 plus 52.5 equals 90. And if I add that to the measure of angle X, I get my 180. So yes, these numbers check out. And that's how you can use trigonometric ratios to find missing angle measures. It's very similar to finding missing side lengths. First, you identify your sides, your opposite, your adjacent, and your hypotenuse. Then you choose the ratio that compares what you know, the two sides that you know. Then you find the value of the inverse trig function comparing the two side lengths that you know. And that's your angle measure. So basic trigonometric ratios are a powerful way to find missing angle measures and missing side lengths of right triangles when you don't know two of the three sides or when you don't know one of the angle measures.